Hi everyone. Now we will discuss about the first sorting algorithm, that is bubble sort. So what is the expectation of a sorting algorithm? So a sorted algorithm will take input a unsorted array which looks like this, and you can see these numbers are arranged in any random order, but we want to output those numbers in, let's say, increasing order, or it can be in decreasing order. So if it is in increasing order, this is how the output would look like. So this is what is the input and output of every sorting algorithm. And now let us talk about our first algorithm, that is known as bubble sort. So it has a very basic idea, like it's inspired, you can say it's inspired from the idea of forming bubbles when you heat up water. Or maybe you can use this example to remember how this algorithm works. Let's say I have a beaker which contains water, and let's say I put a burner here, and we heat this up. Okay, so what is going to happen, you will see at the base of the beaker small bubbles will form. As these bubbles grow in size, they will move to the top of the beaker and explode. So the similar kind of idea is there in bubble sort. What we do, take the larger element, okay, take the larger element to the end of the array by repeatedly swapping with the adjacent elements. So I will show you how this it actually works. So let us take an array of, let's say, 4 elements, 5, 4, 3, 2, and let's say 1. Let's say we have n equal to 5. We have 5 elements in this array, and what we will do, we will take the first element. Okay, we will take this element, and we will compare with the neighboring elements. So we see if 5 is greater than 4, we will do repeated swapping with the neighbor. So 4 will come here and 5 will come here, and we will still have 3, 2 and 1. Next time we are going to compare 5 and 3, and this 5 will move forward. Okay, so we will have 4, 3, 5, 2, 1. Next time we will compare these two, and we will see it becomes 4, 3, 2, 5 and 1. Next time we will have 5 and 1, we will compare, and it will become 4, 3, 2, 1 and 5. So you can see this 5 was a larger bubble, and starting from the beginning of the array, it moved towards the ending of the array. Okay. So this is what happened in, let's say, first iteration. Okay, so we are going to use two nested loops, one for the number of times we are going to do this work. Okay, so this is the work for the first time what we did. Okay, what we did, we iterated from an index, let's say j equal to 0, and we went till the index n minus 2. Okay, and every time what we did a comparison between aj, the jth element, and its neighboring element a of j plus 1. Okay, so this is what we did. Let us talk about what will happen in the next iteration. Okay, let's say we now have these elements. We have this array. Now the element 5 is already sorted. Okay, the element 5 is already sorted. Now we have a smaller array. We don't need to make comparisons till the end. Even if we make, it will not change, because 5 is the largest element, and it is always at the end. So we will have 4, 3, 2, 1. This is the array. That means we need to start from index, I can say we'll start from j equal to 0, and we will go till this index, that is n minus 3. Okay, so we'll compare 4 and 3, it becomes 3, 4, 2 and 1. We'll compare 4 and 2, it will become 3, 2, 4 and 1. And then we can compare 4 and 1, and it will become let's say, sorry, till this index, this is n minus 3. Okay, this is n minus 3. Yes, n minus 1, n minus 2 and n minus 3. Yes, so we will go till this element 3, 2, sorry, this is 3, 2, 1 and 4. Okay, yes, we are going till this particular index, which is n minus 3. Okay, first time we went till n minus 2. So I'm talking about j is going from 0 till n minus 3, because we always need to go till the second last element. Okay, in this array, that's the whole idea. So what we did, we picked a bigger element, that was 4, and we pushed it towards the end to its correct index. Okay, so it is now in the right place. So this is what we do in the second, or second iteration of the outer loop that we are going to put. We again did the comparison between aj and aj plus 1. Let's see what happens in the next iteration. Now we have these elements which are like 4 3 2 and 1. Okay, we have 3 2 and 1 because in 2 iterations 2 elements are already sorted. We have 5 in the right place, we have 4 in the right place. Okay, so 4 and 5, they are already in the correct position. We are not going to talk about them. So this is n minus 1, this is n minus 2, this is n minus 3, but we will just run the loop till n minus 4 because at this position we need next element to compare. Okay, so we will not go to this element. Okay, this element will always be considered because of this factor aj plus 1. So what we will do, we will compare 3 with 2. So we will say, okay, let's compare 3 with 2. So if this happens, then it will become 2 comma 3. Okay, and then we will compare 3 and 1. What will do, it will become 2 comma 1 and 3. So now 3 is in the right place and we are done for this iteration. Okay, so this is what happens third time when we do repeated swapping. And finally, one more time we need to do this work. So what we will do, we will say, okay, we now have only 2 elements in the array that need to be sorted. So these 2 elements are 2 and 1, and the rest of the array is already sorted, that is 3 4 5. We'll start from here. We'll say, okay, swap aj and aj plus 1 if the current element is bigger than the next. We'll swap it, it becomes 1 comma 2, and we will go till n minus let's say 5, only this index. Okay, we start from 0 and we end up at n minus 5, which is this index only, and yes, we are done. Okay, we don't need to do any work. So that's it, and this is how now the final array looks like. Okay, so one observation we need to make is in order to swap n minus 1 n elements, okay, if you want to swap n elements, what you do, if you simply put n minus 1 elements to the right, okay, or to the top, then the one element will be left here, and that would be automatically the smallest. So that we observed that 1 is left here and it is automatically the smallest element. Okay, so effectively we need to do this entire process n minus 1 times, and in this process every time we need to start from the 0th index and we need to go till the n minus 2 minus ith index. Okay, let's say okay, so I will write these conditions in the code, it will become more clear. Let's say this is the number of times the loop is running. First time the loop is running, so we are going from 0 to n minus 2. Second time the loop is running, we are going from 0 to n minus 3. Third time the loop is running, we are going from 0 to n minus 4. And fourth time we are going from 0 to n minus 5. So effectively we are saying that your inner loop, okay, so we have a loop for times and we will have a loop for j. So j will go from 0 to n minus I minus times, something like this. Sorry, n minus 1 minus times, something like this we are going to do. Okay, so if the value of times is 1, so our loop will go from 0 to n minus 2. If the times is 2, our loop will go from 0 to n minus 3. Okay, so this is the whole idea of bubble sort. Now I hope this algorithm is clear to you, and in the next lecture we will discuss the code. Stay tuned.